Hello. For those of you who don't know me, my name's David Gruen. I'm the Australian statistician and the head of the APS Data Profession, which was launched in September this year as one of the professions for the APS. We are starting a new program as part of the data profession, which is a series of conversations with interesting people who have careers in which data plays a very large role. We're going to try and find people both in the private sector and the public sector who have interesting careers and have conversations with them about the role that data has played in their lives and in their careers. We're very fortunate to be talking today in our first In Conversation with Anthony Goldbloom, who is the CEO of a company in Silicon Valley called Kaggle. Today, it's my great pleasure to be able to introduce Anthony Goldbloom for our first conversation. Let me just give you a very short potted history of Anthony's career. Anthony, as you will discover when he speaks, Anthony's an Australian who started his career at the Australian Federal Treasury from February 2007 to December 2008, before spending a bit of time at the RBA in Sydney, and then launching a startup which goes by the name of Kaggle, and nearly 2 years after he launched it, he moved to Silicon Valley, where he now lives. And then in March of 2017, Kaggle was acquired by Google. And obviously, given that data is our topic, data is central to everything that Kaggle does. So, Anthony, welcome to the first In Conversation of the APS Data Professional stream.
Thanks for having me, and I'm pleased you think I still have an Australian accent, because when we moved to America, my father-in-law said, don't lose your accent, it's a sign of weak character.
Well, I think I wouldn't pass you off as an American just yet, I don't think. So can I ask you, the one bit I didn't tell you was that is that Anthony is the CEO of Kaggle, but that will become clear as the conversation progresses. So Anthony, can you tell us a bit about your time in the public service in Australia and how data influenced you in your early roles?
Yeah, sure. So I graduated from Melbourne Uni with a degree in econometrics, and I feel like if you're a decent student, your professors at Melbourne Uni would try and encourage you to do a PhD. And if you wouldn't do a PhD, at least go to either the Treasury or the RBA. That was sort of that was very much the default path. And my first role was at the Australian Treasury in a group called the Domestic Economy Division, I think it was called.
Yep, would have been.
And I was doing some modeling of my first area was the forecasting consumption. So GDP is made up of consumption plus investment plus government expenditure plus exports minus imports. And so I was a part of a small team that had the C, or the consumption component. I think, not sure how this came about, but I think I was more interested in programming, or pretty interested in programming, and was given a really nice opportunity to work closely with a guy called Jim Thompson on a model called the Treasury Macroeconomic Model, I think it was called, or TRIM.
TRIM, yeah, TRYM, that's right.
And it was a really nice model, and I really, really enjoyed working with Jim and learned a lot. I think it made me realize I was kind of very interested in the intersection of programming and statistics and modeling. Really enjoyed working on that model, and it's funny, today my definition of a data scientist is somebody who knows more programming than the average statistician and more statistics than the average programmer, and that, I think, nicely captured I guess it just so happened that I had that combination of interests, and that combination of interests has now become a very kind of sought after, combination of skills. And you have this profession, data science, and obviously, now the Australian Public Service has an official, job classification around this. So I guess through my role at the Australian Treasury, I fell into it, and also had the good fortune of writing, I think, a couple of speeches for you and one for the secretary at the time, Ken Henry. And so it was a lot of fun. I got to work on this model. I got exposure to some senior people in the Treasury Department, which I really enjoyed, and was a very, very happy Treasury employee. I moved to the Reserve Bank, and they were working on more modern economic models. The model was called a dynamic stochastic general equilibrium model. And it was funny, the Treasury TRIM model was considered to be older technology and not as fancy. It works so much better. And so I described the dynamic stochastic general equilibrium model that we were working on was maybe very intellectually challenging, but completely useless. And I found that a fair bit less satisfying.
So for those people who are interested in following up after this conversation, you can put Gruen and Goldbloom into Google, and you will find the speech that Anthony wrote for me and that I delivered to a Nat Stats conference for the ABS. So I don't know what goes around comes around, and I've ended up as running the ABS, and Anthony's ended up in Silicon Valley working on data. But it's actually quite funny to go back and read that speech, because a lot of the things that we're now doing were foreshadowed, at least to some extent, in terms of where data might go. And that speech was delivered in 2008, so that's 12 years ago. So I think we have made substantial progress since then. So tell us how you went from a restless treasury, a treasury analyst and RBA analyst to creating a startup.
Yeah, I think there are a couple of things that happened. So one was when I moved to Sydney, I moved because I wanted to move to the RBA because my wife got a job at a law firm, and she could work in Melbourne or Sydney, and I could have a similar job to the job I really enjoyed at the Treasury in Sydney at the RBA. So that was the trigger. She was a corporate lawyer, and so I worked for the government. I worked from 9 till 5, and she worked from 8 till 11. And so I had these 6 hours in the evening every night to kill. And so I started working on this idea for Kaggle in the night times, and it was really triggered by I used to subscribe to this newsletter called KD Nuggets. It actually still exists today, and it was KD stands for knowledge discovery, and it was knowledge discovery and data or data mining was the word, I guess, of the moment for people who enjoyed combing through data and finding interesting insights using automated algorithms. I used to subscribe to that newsletter, and they would always talk about there was this academic conference called KDD, and every year they would host something called the KDD Cup, which was a competition that you would enter. If you finished in the top 3 in the competition, you got a speaking slot at the conference. And I always thought that was very elegant. The alternative routes is quite a prestigious conference. The alternative routes where you write a paper and it gets accepted or rejected. And I always found the idea of a competition far more meritocratic. And I quite like the idea of bringing this competition concept that was used nicely by these KDD conferences into industry. I was also kind of curious about what would happen if you took some of the economic modeling problems that I was working on and opened them up to a wider audience. And so that's what I was doing, working on Kaggle at night. And I think I calculated, maybe after doing this for 3 or 4 months, I calculated I was a very slow programmer. So I calculated it was going to take me too long to finish the website. And as I foreshadowed, I think I'd been very happy at the Treasury. I wasn't finding the Reserve Bank quite as fulfilling. At least it wasn't as good a fit for me. And so that was the thing that triggered, the fact that I wasn't loving my job and was really enjoying what I was working on at nights. and wanted to wanted to see if I could make a go of it. That was what caused me to leave the RBA and work on this full time. And so I went from my wife working from 8 till 11 at a corporate law firm to me working from 7 to 12 on my startup, and eventually launched it in April of April of 2010. And I remember thinking all I need to do is code up this site and then it's going to be I put it on the internet and it will be successful. It was extremely naive. And of course I coded up the site and turn it on and it's like, what happens now? And the way I got Kaggle off the ground initially, after the shock that when I launched this website, no one was coming to it. What I guess I intuitively realized is it's quite hard to sell companies on putting competitions up without having a community, and it's quite hard to have a community without having companies posting problems. So there's this sort of classic cold start problem for two-sided markets, and I've subsequently learned and applied this unwittingly. The idea that if you're trying to get a two-sided market off the ground, you need to build the easier side of the market first, and then you fill in the other side of the market. And so what I used to do was put together the problems myself and post them on Kaggle. And so the first problem I posted was around the time my wife is obsessed with the Eurovision Song Contest, and they have these interesting voting patterns where, Germany votes for Turkey because there's a lot of Turks emigrated to Germany, same with Israel and ex-Soviet countries. So there's all these quirky voting patterns. So it was a nice statistical problem. And so that was the first competition I launched, and then slowly launched more and more, then got some academic competitions, and then started getting my first Fortune 500 customers were Allstate, which is an American US insurance company, and then Tesco, which is a British grocery store chain. And so that was the early days of getting Kaggle started.
So do you want to tell us a little bit more about how these competitions work? As in, once the two-sided market is operating, namely you have problems up on the website and then you have a community of people who are going to try and solve them. Do you want to give us a bit more idea about how that all ends up working out?
So how it works is a company will approach us with a problem. So let's take some of the early insurance problems. An insurance company cares about predicting who's going to crash their car, and so what they'll do is they'll give us the records of many of their customers, some who went on to crash their cars or make an insurance claim, and others who didn't. And what we would do is we would divide that data set into two parts. On one part, we would give people the answers. That's called the training set. And then on the other half, we would withhold the answers. And so what people would do is everybody had access to the training set, and everyone had access to the test set, but the test set didn't have the answers.
I presume this is all de-identified.
Yeah, exactly. And actually, I can talk about how some of the clever de-identification tricks in a moment. But what then people do, and then we can score objective when people submit their answers on that hidden set. We can score whose algorithm was most accurate. In the case of the insurance, the Allstate example, there were some clever things that we did. One thing we did was, aside from de-identifying a lot of the features of the policyholder, we also were predicting the residual rather than whether somebody crashed their car or didn't. The idea being that Allstate already had a model, and what they were really looking for was a model that found things that their model didn't find. And so there are lots of clever tricks that one can do to disguise the data, both for privacy reasons and for competitive intelligence reasons, so as not to leak information to other companies. But yeah, that's how the competitions worked, and that is, there are some nuances now. We've got some more sophisticated approaches, but by and large, that's what a competition looks like even today.
And at the end of the day, the winning algorithm is then shared with the company that has given you problems, so that what they end up with is a better algorithm to predict whatever is the technical problem that they've set, and there's a financial benefit for the people who came up with the answer. Is that how it works?
That's exactly right. Yeah. So what we do is we'll pay prize money. Actually, typically we'll pay to the top three, or sometimes top five. And the idea is that in exchange for the prize money, they give the IP, normally a non-exclusive license over the winning algorithm, to the company. The reason we do the top three to top five is, particularly nowadays, we'll get thousands of people competing in our competitions, and it's typically the case that the difference between first, second, third is not statistically significantly different. The difference might be, it's actually very interesting when you have a lot of people competing in a competition, you get to the point where the top teams all converge on the same answer. They're not necessarily using exactly the same algorithm, but the idea here is there's only so much signal in a data set, right? And if you have enough smart people looking at the problem, you get to the point where, given the state of the art machine learning and whatever richness is in the data set, you extract all the signal out of the data. And that's really, that's ultimately the selling point for these competitions. Allstate, the insurance company, could spend many, many, many years trying to iterate on a problem, not really knowing whether it's possible to do better or not. Whereas they can come to Kaggle, they put the problem up, and at the end of running a challenge, they know that given the data set they used, this is as good an algorithm as you could physically possibly have on that particular data set. So it's quite compelling for companies.
And what are the characteristics of your community, of the people who have become data problem solvers for Kaggle problems?
Yeah, it's really it's changed over time. Actually, interesting. The winner of the Eurovision competition has now become a very well-regarded researcher in Facebook's AI lab. At the time, he was an undergraduate at the University of Ljubljana in Slovenia, really not at all on the map. And so one thing that comes from a Kaggle competition is it takes people who might have been under the radar and gives them an opportunity to prove themselves, or to demonstrate their abilities. And so very often, at least historically, very often you would find people from just fairly unexpected backgrounds. Some of the characteristics of top performers in terms of geography, Eastern Europe does very well, and I think that's because math and science education is really emphasized there, in the same way that I feel like in Australia and the US, other professions are more prestigious. I think maths and science in Eastern Europe is very prestigious. China and India do very well. Perhaps not surprisingly, the US does very well. Some of the characteristics of those who do well, just from their personal attributes, I feel like there's a bunch of things that are common. Firstly, you have to have a baseline programming ability and a baseline statistics ability, and above and beyond that, they're often very tenacious, because what happens is, you're coming first on the leaderboard, and then somebody passes you. You have to sort of stop and think, okay, somebody found something I didn't find. You've got to be tenacious enough to keep trying.
Right.
Very often they are also creative. So you need to find something that other people didn't find. So one of my favorite examples is we ran a competition to predict which cars bought at a secondhand auction would have a warranty claim against them. So basically, which cars are good buys and which ones are lemons. This was for a large car dealership. One of the winning insights was car color made a difference, and what they did was they grouped car color into standard color cars and unusual color cars, and unusual color cars were more likely to be reliable. And the hypothesis they were testing was, if you're the first buyer of an unusual color car, you are an enthusiast. Therefore, you look after the car better. Therefore, by the time it's sold at a secondhand auction, it's in better condition. And they tried many, many different combinations. Dark color cars versus light cars, on the assumption that dark color cars get into more accidents at night. No relation. The vast majority of things that are tried have no relationship.
Power. Right.
Yeah.
Yep.
And then
but it turns out that this one does.
That one did, yeah. The unusual color and usual color card one did, and then the last characteristic is, I guess, particularly disciplined with respect of overfitting. One common thing that we see happen the first time somebody competes in a competition. I forgot to say this, by the way, with the hidden data set, show you the results on a live leaderboard on half of that hidden data set. But
Right.
then when we finally score the competition, we throw that away and we retest you on a portion you've never seen any
Right.
answers
Right.
on.
Right.
And very often what happens is the first time somebody competes in a competition, they'll be doing really well on the public
Right.
leaderboard that we show during
Right.
the competition, and then we switch over, and they've dropped. You
Right.
know, they'll have this experience. It's midnight. They're hitting refresh, refresh, refresh on the leaderboard, knowing we're about to show the real results, and they think they're in for top 10, and they have to keep scrolling and scrolling and scrolling. And what has happened is they've overfit.
Right.
And
Right.
I tell you what, wonderful way to learn not to overfit is to
Right.
have that happen to you.
Yeah. Yeah.
So yeah, another common important characteristic is having robust methods against overfitting.
Right. No, that's fascinating. You made the comment in your last answer that kind of data profession is kind of high status in Eastern Europe, but less so in Australia and the US. I'm wondering, given the sort of increasing importance of data, both for the private sector, but also for the public sector, whether you think that might change.
Oh, actually, sorry, I should say I absolutely think, yeah, I should caveat that. I think that's probably a little bit of a historical perspective.
Yeah.
Certainly, I haven't been out of Australia for a long time, but certainly, if you're a software engineer or a data scientist in Silicon Valley, you are totally top of the tree. You'll
Right.
never be without a job, and I suspect something's. Having not been in Australia, I'm not, quite as aware of what. What trendy professions look like, but I would imagine it's probably similar in Australia.
Yeah. Yeah. I mean, one of the phenomena is that often people get training in the public sector, and some of them decide that they find public sector work really interesting and they stay.
Mm.
And for others, it's training that turns out to be very useful in their later careers. And I'm
Mm.
wondering, as the data profession becomes better established, which is what we're trying to do in the public sector, whether we'll have a similar model, that is that it's a good training ground and you learn about a range of different sort of data intensive issues, and then you may find that public sector work is very much to your liking and you'll stay, but for other people it's just a pathway to alternative careers.
Actually, just a
Yeah.
quick comment on that. In my experience, one of the things that attracts people to different organizations from a data perspective, if you're into data science, is the quality of the data you get to work with. And I think in
Yeah.
many cases, the public service has a real advantage there because the nature of the data that you might get access to is probably particularly, I would imagine at the ABS, you have access to data that you get access to in very, very few other places.
Yeah, yeah. No, I think that's probably right. And also, we're trying to do things that are at the cutting edge often, and so you're doing, and that's not just true of the ABS, but it's also true of other parts of the
Mm.
public service where increasingly there are big data assets which both integrated and also big data assets in their own right, like single touch payroll, where there are
Yeah.
just new and interesting questions to be asked, and you're the first people to be able to get access to them. So I think there's definitely something to that. So Kaggle has, and its community's been doing work with the White House and the COVID-19 open research data set. So I'm just interested in whether whether you've found, whether there are problems that you've hoped to solve that are kind of are public policy type problems.
Yeah, I mean, we have been working earlier this year. We were working with the White House Office of Science and Technology Policy on that COVID challenge you mentioned, and what they had done. This is a challenge I'm quite proud of, somewhat related to public policy. What they were the challenge they were facing is when COVID first started to really make its way to the US, it was early February, and maybe there were 5 or 10 academic papers a day. By the end of February, there was 20 to 30. By mid-March, there was 30 to 50. By the end of March, there was 50 to 100. No one can
Per
read
day.
50 to
That's
100 per day. And
Yeah,
I think
right.
we're up to somewhere in the order of 1,000 now. Nobody can read that many papers.
No.
And so what they did is they collaborated with all the journals, the leading journals, and they had them open access all their COVID-19 research. And then they put that the publicly all the open access papers on the Kaggle website, and they had challenged our community to build tools to synthesize the literature. And so a lot of the things the community did, it was really quite nicely done, was do things like try and figure out what the incubation period, extract from the massive corpus of papers what different studies were saying about the incubation period of the virus. And if you know the incubation period, that helps you set your quarantine policy. Is it 14 days? Is it 7 days? That's just so. I think this was this project had a nice impact early on because we were able to really synthesize pretty efficiently what the academic literature was saying on a bunch of key COVID-related questions. I think the project now is a lot less useful because I think you got to a point where we had a solid understanding of what the incubation period was. For example, we got to the point where we had a solid understanding of what the risk factors were for a severe response to COVID-19. And so I think the project had was useful in the early days as governments around the world were trying to wrap their arms around what the literature was saying. And actually, maybe so I think that was a nice public policy example. Kaggle's worked with the Census Bureau in the US on predicting response rates to the US Census in order to. What they do is they employ door knockers
Not just
and they
them.
need to. Yeah, right.
We do too.
You do too. Yes.
Yeah.
Well, in their case, they were trying to figure out, where these people needed to be hired. If the return rate was going to be lower in one state versus another, you would hire more people. So it was part of their census. I forget which census it was, but they used it for their planning purposes.
Right.
There's a bunch of examples like that, but that one came to mind because it struck me as one that was relevant for the ABS.
Do you think there's a kind of burgeoning opportunity for public sector and private sector collaboration on data projects?
Absolutely. I think one of the biggest opportunities, one of the biggest unrealized opportunities, let's take this from the perspective of the private sector. First of all, is there is a wealth of data publicly available, often generated by governments, that is not really taken full advantage of. In the private sector, as one example. On the flip side, my suspicion is when you're doing things like putting together a consumer price index, there's probably a lot of ways. I know there's probably a lot of ways you currently collaborate with the private sector to get surveys of prices. But I also wonder whether there aren't opportunities to do things like there is a company. I actually don't know if they're still doing this, but there was a company in the US for quite a long time that was paying people to go around and take photos of labels in retail stores just to get prices, and they were selling this to hedge funds as like a fast read on the CPI in the US. So there's probably like clever ways that the private sector are using data and generating data that could be interesting from a public sector perspective, and I also suspect there are opportunities for the public sector to use private sector data more intensively.
Yeah, we're certainly doing that. In fact, for quite some time, the ABS has been getting scanner data from the supermarkets and using that to get a read on prices for products sold in grocery stores, but also web scraping. So we also web scrape. So there's no question that getting access to private sector data is something that I think there's an enormous opportunity to generate public value from, and that's a growth industry, and so there's no question there's quite a lot of that going on. I guess I was going to get you to reflect a bit on the future and just have a think about where. I mean, obviously, the value of data has gone up enormously over the past few years or perhaps decades, and it's become much more ubiquitous. But do you have a sense of, is it just going to be more of the same the next 5 years, or are there trends that you think are going to be different and disruptive? I suppose AI is one area of that, but I'm kind of interested in what you think.
Yeah, absolutely. I think that I don't love the term AI. I think it's a little bit, machine learning is the term I prefer to use because I think it's more precise and it's really the branch of AI that's been that's most impactful. If I think about the history of machine learning, at least over Kaggle's lifetime, Kaggle really started at a very interesting time. We started when there was or maybe it was sometime after the invention of an algorithm called random forest, which is a very, very powerful algorithm. When I went to college, we learned logistic regression and linear regression and all these things. And
Yep.
you'd get told at the beginning of the lecture, this is a legitimate way to train or to build a model if these 20 things are true that are almost never true. Your data is normally distributed and all this stuff. And so random forest was very powerful because it's what's called a non-parametric model, so relies on very few assumptions. Of those simplifying assumptions. And so, through Kaggle, we were able to demonstrate that random forest was a very powerful way to train models on structured data, things that fit in an Excel spreadsheet. Then the next big development, and this is where the whole AI craze came from, was in 2012. A lab at the University of Toronto demonstrated that neural networks were very powerful for training computer vision problems. And so now you get all these crazy things, like if you use Google Photos, I can search, Annabelle is my daughter's name. I can search for Annabelle and it will show me all the pictures of Annabelle. I can search for kite. I'm a kite surfer. I can search for kite surfing and it will show me all the pictures of me kite surfing. You're starting to get these really cool applications, not to mention a lot of the autonomous vehicle applications. I'd say in 2018, we had another big breakthrough that has not really been realized. So now we're coming to future trends. Another big breakthrough that is not yet made its way into industry and into a lot of the products we regularly use, but there was a big breakthrough in natural language processing. So the ability to read and understand natural language. And so, some of these algorithms are starting to, you might have noticed Google search has gotten a lot better at some very nuanced queries. It's now doing a better job than it used to. And that's thanks to the advances in natural language processing. I think you're going to see a lot of interesting chatbot technology. So, it's interesting, like, it used to be that structured data was the only valid data, and then the 2012 innovation meant you could do more with images, and the 2018 development means that you can now do more with text as well, which opens the range of possibilities. So those are the things that I think are on my radar as, at least within machine learning, as large developments. The other thing is that the other area where more on the data analytics side, where there's been a lot of progress, is there's now a lot of libraries, things like Dask, that make it very easy for you to process and query, and data warehouses like BigQuery, which is out of Google, and then another company called Snowflake, and they make it very, very easy for you to query very large volumes of data. It used to be the case that if you wanted to query a massive amount of data, you might have to subsample, or it would take you many days. Now, the way some of these technologies work, they just distribute the query across many, many, many machines, and so you can query much larger data sets. And I think that also is something that opens possibilities that may not have existed a decade ago.
I can't help thinking that these things will have public policy implications, that there will be things that will enable better services to be provided to the public from the or for that matter advances in kind of research of being able to tackle public policy problems. Do you have any reflections on that?
Yeah, I mean, one, there's certainly things like there's certainly some challenging public policy issues. There's certainly hot topics in the US, like the ability to do facial recognition at a much more accurate level than ever before. And so, that could be a powerful tool for things like policing and law enforcement. But then it also has some privacy concerns associated with it. So I think a lot of these technologies do have some powerful public policy potential, or potential to be used in the public service, but also very often, there can be open questions about, privacy is often a big one.
Yeah, I mean, I think maintaining as these techniques evolve, maintaining the trust of the community that what you're doing is kind of in their interests is kind of has to go hand in glove, certainly with the public policy applications of these things. Because if you unless you keep the confidence of the public, there will be, these things are just not going to be able to happen. Let me change the subject slightly and ask you, how do you keep up to date with developments in data science?
Yeah, I mean, actually, this is probably an area where at least for many types of problems, Kaggle really shines, and is one of the reasons we have a user base of about 5 million users. And one of the main motivations for a lot of users is it's a good way to see what is working at the cutting edge of machine, or what new developments in machine learning really work on pragmatic problems. One challenge you have is every academic paper you read will say, I benchmark my method against these 6 other methods and mine was better. And then you look at the next paper and it says the same thing, and you look at the next paper and it says the same thing. And it's very difficult to, you can read 50 papers and really not have a great sense for what you should be paying attention to and what you shouldn't. And so there's something very elegant about, that you have a competition, you see what wins, you see the top 3 were all using a similar method, on a problem like the problem that they were competing on, that method is a good one to use. And this is really nice. Kaggle is now built up, which we've hosted hundreds and hundreds of competitions at this point, and very often, unless the competition host doesn't allow it, the winners will share the basic recipe that they used, and that ends up being a really, really, really nice resource for keeping track of, what is working, not just at the cutting edge of machine learning, but what actually pragmatically, what pragmatically works on real world problems.
Yeah, that makes sense. So let me, since the members of the audience who are going to be listening to this, some of them are just starting out in a career using, using data, and I'm wondering whether you have advice for someone who's just starting out and kind of has a taste for data and finds working in a role that's data intensive satisfying. And I'm just wondering whether you have thoughts for that person about what they should look out for.
Yeah, I mean, this may be a little bit a little bit tactical and a little bit nitty gritty, but one rule of thumb that I've come to develop is whenever I'm playing with data and something looks odd, digging in, like I've found that chasing down anomalies almost always leads somewhere interesting. So when you see something anomalous in data you're working on, very often your reaction is to think, oh, that's inconvenient, I wish that anomaly wasn't there. I think in the cases where I have taken the opposite perspective and gone and chased it down, very often there has been a very interesting insight at the end of it. And so that's maybe at the more tactical level. I mean, at the, zooming out a little bit, I think I personally think it's a wonderful field to be working in. I feel like every data set has its secrets, right? If you can, if you master the tools, whether it be SQL or Python and Pandas or some of the machine learning algorithms, these are all tools that allow you to interrogate the data in different ways and pull out its secrets. And so I find it, I obviously have a day job running Kaggle, but I spend a lot of my spare time playing with data sets on Kaggle that interest me, uploading data sets to Kaggle that interest me. Like I think a really wonderful, for me, it's a passion, and I'm very lucky to also work in something I'm passionate about. And to others who are in a similar situation, I think we're very lucky.
Yeah. No, my advice to people is your career, you're going to spend a lot of time doing it. So make sure you do something you find enjoyable and interesting, because
Totally. Yeah.
otherwise you'll look back and think you'll and regret it. So I completely agree with that. It's important to the extent that you find what you're doing interesting and enjoyable, and it pays the rent, then that's as good as it gets, I reckon.
Totally.
So are there, for someone who wants to go from here and read more widely, are there blogs or podcasts you'd recommend?
Yes. I'm just thinking. I'm going to give you a biased perspective, which is I think
That's all
anybody who
right.
wants to yeah, I guess I think Kaggle is a very rich resource in that not only do you get to play with data sets, but you get to discuss, like as you play with them, you get to discuss them with other people at the same time and read their approaches to the problems. So that's my biased perspective. Let me see
Yeah,
if I
that
can
is
give
your
you an
biased perspective. I'll give you that.
unbiased perspective. I think there's some courses online that are very strong. There's one called Fast AI, which is very good. Kaggle has some learning courses as well, which teach some of the machine learning methods as well as other approaches to data. I think that there's a podcast that I quite like called Gradient Descent, which is I think it's what it's called. Maybe it's not called that. It's by a company called Weights and Biases, and it's interviews with people who work at companies, whether it be iRobot. They did an interview with somebody at iRobot. They built the Roomba, and you get to hear about the data science, machine learning that goes into the Roomba automated vacuum robot.
Yes, right.
Yeah, and then the next week they'll interview somebody who works at oh man, they just find very interesting interviews with people working with data from lots of interesting companies. So that's another one I recommend.
Okay, that's great. And any other thoughts for someone who's kind of in the public sector who's working on data, other than to leave the public sector and go and work for Kaggle? We're not that advice we'll probably edit out of this interview, but
I'm not sure that would be my advice. I think the data that you get working at somewhere like the Australian Bureau of Statistics or the Australian Tax Office would be as interesting as data you would get access to anywhere, to be honest. And as much as I wish it wasn't so more interesting than the data you'll get to play with at Kaggle.
Oh, very good. Well, we can't complain about that answer. It actually it's something that a professor and someone who used to teach me used to say that until he went to the public sector, he didn't realize just how quickly people in the public sector got access to the sort of cutting edge problems that academics certainly don't find out about until afterwards, because the new problems kind of present themselves, and often it's the public sector that has to grapple with them. That's certainly been true in terms of coming up with sensible responses to the COVID-19 pandemic. So I think that is often the case.
And just actually to riff on that a little bit, I think one challenge with academia is if you're in the public service or you're at a company, you have access to you most likely have access to data. One challenge academics often have is getting access to data. Data's like gold. It's a form of currency in and of itself. And so
that's right. So I'm just wondering whether I was going to kind of wrap it up fairly soon, but I was just wondering whether there were any other reflections you had, I guess, either on your looking back on the time when you were in the public sector, or reflections on sort of other advice you'd give to people who are working in data roles in the public sector.
Yeah, I mean, I love my experience at the Australian Treasury. I think of it very fondly, and I don't know. I think I liked it. At the time, I was playing with interesting data and interesting problems and learning from interesting people. And so, if to the extent that's true, for those in the audience, we spoke about this before, but it's a very nice place to be. But not much more to say beyond that.
Okay. Well, look, we're very grateful to you for taking this precious time and for sharing your insights about what an exciting time people can have working on data. And so thanks very much.
Thanks for having me. And who knows, when we go and check the election after this interview, maybe it's all over.
Thanks very much, Anthony.
See ya.
Bye-bye.